Hey, hello. Hope everyone is doing good and great today. Today we are here to discuss about verification and validation of a simulation model. So let's get started. Today we are taking a simulation model to describe its verification and validation of its model. Today we are taking about discrete event simulation of appointments handling at a children's hospital call center. So hospital call center is a simulation model we are taking in the study. I mean, these are the authors for this published case study, and I had took this case study from Winter Simulation Conference. So the hospital considered in this work was facing a high level of abandoned calls and low service level, incurring in missed exams and consultations, resulting in decreasing the income for the institution and service quality for its patients and other stakeholders. The figure here shows the two main KPI, key performance indicators, that is of abandoned percentage, which measures the percentage rate of abandoned calls when compared to the total arriving calls, and service level rate, which measures the percentage of inbound calls that wait less than 10 seconds in a queue. Although the automatical call distribution ACD system already installed in the hospital has been updated for its latest version, the management team was unable to use any method to identify the root causes of the problem. In order to improve those KPI, key performance indicators, therefore we are introducing a discrete event simulations has been chosen to guide them in their decision making. The aim of the project was to evaluate via discrete event simulation the appointment process of two service channels, exams and consultations, for a children's hospital in Brazil, in order to identify improvement points in information and communication technology ICT infrastructure, enhancing answering services, and consequently reducing the number of abandoned calls per day with higher service levels, showing the advantages and viability of this tool. So the main objective is here the received calls in a call center. This hospital is facing lot of abandoned calls and service rate is really low. As seen in the picture, it's almost dipping 15 percentage examination appointment and 25% of service rate, and decreasing in a lot of low income sources. So they're opting for discrete event simulation package so that they can check and improve their business performance. Let's see the conceptual model of the process. See, the conceptual model of this process is there will be two wings, that is exams appointment and consultation appointments, and need to follow these concept. I mean, they need to follow this queue followed by these agents, I mean their representatives, and then exit. This is the actual conceptual model how the call center works. So regarding the call handling process, the study considered by the global times from the moment that the call is answered by two systems, exams and consultations, passing through the queues until agents hang up. The same skill could be considered for the agents since the study did not identify any considerable answering time variations between them. There will be some time variations between them, such as withdrawal times, coffee breaks were considered as agents. Inefficiency in the simulation model. For the exam appointment, the hospital has three agents working for the hospital. For the examination, for the exam appointment, working from 8 a.m. to 9 p.m. And for the consultation appointments, there are two agents working from 8 a.m. to 6 p.m. So basically, the calls for exams appointment lasts from 8 a.m. to 9 p.m. and for consultation appointment lasts from 8 a.m. to 6 p.m. So three agents are working in exams appointment and two agents are working in consultation appointment. So this is the basic conceptual model how the call center works. So let's see the data analysis. of the real data. So these are the call arrival rates on Monday. So we are trying to graph some real data so that we can build our simulation model. So the red graph indicates the examination appointment call hours, and the blue one indicates blue graph indicates the consultations appointments. So and the green one indicates the total call hours. I mean the total call moments is a real data considered from the data analysis. So the call arrivals was obtained from the software used by the institution that managed the call center called CCS with a 6 months historical database of daily calls from March to June 2017. So the figure has a data from March to June 2017. So analyzing the graphs from each day of the week, it was possible to conclude that the behavior of is the same as described for Mondays. It is possible to notice a peak in the morning from 9:30 a.m. to 12 a.m. and in the afternoon from 1:30 to 4:30 p.m., showing a dip in the lunchtime from 12 a.m. to 1:30 p.m. A low call flow from 8 a.m. to 9:30 a.m. and 4:30 p.m. to 7:30 p.m. is observed. So by taking the real data, so that we can, based upon the real data, we need to design our network. We need to design our simulation model. This is the real simulation model by analyzing the real data. Let's start with chronological analysis. Chrono analysis. So the exam appointments, these are the data of exam appointments, and this is the data of consultation appointments. So real data it's used to frame the network. Based upon this data, we're going to design the simulation model. So it was necessary to proceed with a chrono analysis to confirm the agent's answer time, the withdrawals, and most importantly, it was possible to identify different type of services. For exam appointments, four type of services were identified. First contact, which is of 27.67% of total call volume, and appointment lasts for 26.74 and the total of total call volume, and doubts of 35.93, and transfers of 9.65. So even with the consultation appointments has 30.51 of total call volume and transfers of 16.45, and doubts and rescheduling is 53.04 percentage. Based upon this data, we are going to design our network. Based upon that percentage, we are going to categorize the call flow of a simulation model. Let's see the simulation model of exam appointment. So there are two different simulation models. One is for exam and one is for consultation appointment. So let's see the simulation model of the exam appointment. So this is the simulation model designed for exam appointment in this article. So here right on screen we can see the calls arrival and then followed by the queue. After that queue, the call is routed based upon the first contact queue and appointment queue and doubts of the queue and transfer queue. After that, then all they are routed for their individual agents and then followed by the main queue, then followed by the phone ring. And if you consider this flow, the phone ring is then followed by the call answering. After the call answering, then is a proper examination is being done to the patient, and then he need to be get exit. Suppose if the phone ring it got abandoned, then it will go into the exit. Let's see the consultation appointment simulation model. So right from the call arrivals, then it followed by the queue, then call routing is done for appointment queue, then doubts of the rescheduling queue and the transfer queue, then individual pieces will handle and then route it back to the queue. After the phones ring, then it's followed by the phone ring then goes to the queue again and then call answering, and after the call answering, then if the consultation is done, then the customer is routed back to the exit. Suppose if the phone ring is abandoned, then after some time it will go exit. Suppose if every agent is busy, then it's abandoned, calls will go to the exit. So basically the flow will be designed in this statistics, based upon the statistics. So let's discuss some statistics regarding this. So a critical situation for the hospital operation is abandoned calls. In the exam appointment case, 48% of the abandoned calls occur with the telephone still ringing and the other 52% in the queue. For the consultation appointment, 40% of the abandoned calls occur with the telephone still ringing and other 60% in the queue. Analyzing those groups for both services is possible to conclude the customers to be answered due to the critical service tending to abandon after 60 seconds. So 42% for exams and 55% for the consultation. So based upon these statistics, we are going to design the flow. Another relevant situation found in this operation was the fact that agents do several activities such as coffee or restrooms, meetings, feedback, small talk, personal matters, internal calls. So based upon all these dynamic situations, we need to design the simulation model. So for this, all data gathered were treated and processed to statistical fitting software in which mathematical probability curves were found for service levels and abundant profiles. In order to implement this simulation, we need to consider some hypotheses for this. There is first hypothesis, there is no skill difference between the agents. First hypothesis. The second hypothesis is time of outgoing calls, external or internal, made by the agents were considered by the total availability of the total availability, except none of them who proceeding to some external outgoing calls in order to confirm the schedule time. The third hypothesis, the distribution time between calls, was considered exponential due to unavailable data source. And the fourth hypothesis we are going to consider in this model is during chronoanalysis phase, the verified average withdrawal time was 20 minutes per day for both services and was also included in agents availability. And the seventh hypothesis, in consultation appointments, a backup agent was considered whenever one of the two regular agents was unavailable. The simulation model created in simulate software for examination appointment. So these two simulation models is generated by by using the simulate software based upon this hypothesis, based upon the data we have. So based upon all these hypotheses and the variables and the data, we will design the simulation model. So right up to now, we use the different constraint data and build a simulation model. Now we're going to check with the how we build a simulation software using the conceptual data, and we generated a computerized model. So now we are going to check with the verification and validation of the model. So up to now we generated a model. Now we're going to proceed with the verification and validation. So let's start with verification and validation of the simulation model. What are the verification and validation steps that are used by the author in this simulation model? So first, let us know what is meant by verification. So verification is nothing but it's a process of determining that a model implementation and its associated data accurately represents the developer conceptual descriptions and specifications. And validation is nothing but the process of determining the degree to which a simulation model and its associated data are an accurate representation of the real world from the perspective of the intended use of the model. So what are the verification techniques that used by the author or modular implementation, that is modular verification, which is a computerized, which comes under the category of computerized model. It is also represented by our this week readings by the author Sargent. And another verification procedure used by this simulation model is the graphic analysis. It's also represented by this week's assignment readings, that is Sargent. So modular verification comes under computerized model verification. This verification is done when it is written in high-level programming language. So basically, we use high-level programming languages such as C, C++, and Fortran. It is a high-level programming language has been used for this. Then the computer program should have been designed, developed, and implemented using these techniques found in the software engineering. These techniques include object-oriented design, structured programming, and program modularity. In this case, verification is primarily considered with determining the simulation functions, that is the time flow mechanism and pseudo-random number generator and random variable generators. And the computerized model have been programmed and implemented correctly. So the next verification step that used is the graphic analysis. The behavior of the data of the simulation model and the system are graphed for a various set of experimental conditions to determine if the model's output behavior has a sufficient accuracy for the model's input purpose. So we will discuss about the model's inputs later on after discussing the validation techniques. So now we will discuss about the validation techniques that we used. The two validation techniques are the operational validation and paired t-test. So, operational validation is determining whether the simulation model output behavior has the accuracy required for the model intended purpose or the domain to the model's intended applicability. This is very much of the validation testing and evaluation takes place. Since the simulation model is used in the operational validation and any deficiency found may be caused by which was developed in any of the steps that are involved in developing the simulation model, including the developing the systems theory of having valid data. So the next validation technique is the paired t-test. So let us discuss about what are the inputs we generally use that to analyze the following KPI, performance indicators. So first data is the call arrivals, average queuing time, average answering time, service level agreement, abundant calls, as abundant after calculating by using this t-test, it almost shown the 95 percentage of confidence interval for the difference between real and simulated data includes the value 0 for all KPI studies. So after using this t-test, the KPI's confidence interval raised to 95 percentage, indicating the model validity. So now let's see the calculations of all stuff. So right now here we shows the pay T calculations. This slide shows the pay T calculation, how the confidence interval 95 percentage is built by using this data, real data, and simulation model. So the KPIs are in this I mean in the left side of the table, and the consultation appointments and the examination going on the other sides. So the call arrivals and all this data has increased the confidential interval 95% shows the validity of the simulation model represents the real situations. So basically the data we usually take from the real situation that was shown in the previous slides, the data using that data we use the t calculations, and finally we got the confidence interval of 95 percentage by using all these KPI constraints. So after studying this simulation model, I had some few suggestions for the simulation model, what I had observed, what I feel are. So if they use the degenerate test, historical data validation, and sensitive analysis. So I suggest these three test more validation techniques to make the simulation model to bring more realistic situations. So, so we are dealing with a simulation model when we consider the limited number of inputs. So there will be a lot more number of inputs to be considered before we are dealing with simulation model. There are a lot more inputs like arrivals of the call timings and traffic queued or refused, call flow and routing, call overflow, abandonment, retrials, call handling time, prioritization between different types of call, agent ability, their efficiency, interactions between the events, queuing priority, and the call types. And the agent's availability, they may go for a coffee break or whatever. So the agent inavailability. So based upon these factors also we need to develop the simulation model. So it's not possible to give all the inputs to generate a simulation model. So we are using a limited number of inputs. So if you consider more number of inputs, if you consider more number of inputs, more number of data, that realistic the simulation model will be. And And let's also discuss about this degeneracy test and everything. The degeneracy test, the degeneracy of the model behavior is tested by appropriate selection of the values of the input and internal parameters. So the behavior is tested by the appropriate selection of values. So by considering all the inputs and all the input parameters and the internal parameters, we can build a better simulation model. And the next suggestion is the historical data validation. So if historical data exists, that is data collected on the system, which was used in the previous slides like the CC, part of the data is used to build the model and remaining data are considered to determine the test. So the part of the data is used and are used to determine the test whether the model behaves as a system. So the data what we possess and we need to implement in our simulation model so that it builds a realistic simulation model. So and next is the conduction of the sensitive analysis. This technique consists of changing the values of input and internal parameters of a model to determine the effect upon the model's behavior or output. The same relationship should be occur in the model in the real system. So the technique can be qualitatively directions only of outputs, and quantitatively both directions and magnitudes and outputs. Those parameters that are sensitive, that is cause significant changes in the model's behavior of output should be made sufficiently accurately priorly by using this model. So these are the suggestions what I feel when I follow this simulation model, what I read our today's our this week's assignment, what I feel. These are still more validation techniques required and verification techniques, basically I feel, for validation of simulation model. Thank you everyone. Thanks for your time and consideration. This is the simulation model I had used, and these are the validation and verification techniques that the author used in this simulation model. Thank you everyone. Thanks for your time and consideration.